So I'm Paul Baclace, and I'm going to talk to you about my experience with setting up a PDF classifier using an ensemble of models in order to classify documents. And so let's see, next page, here we go. Okay, so here's my background. So briefly, I started with Hadoop. I've been working on that since the beginning of time there with Doug Cutting. One day he came into the office and said, we're cutting off the bottom layer of Nutch and we're going to call it Hadoop. And so at Inner Archive, and by coincidence, I'm going to be, I'm actually doing machine learning at Internet Archive now. And so I switched to doing machine learning, deep learning about 2 years ago. And there you have it. The let's see. Okay, so what do they want? So the this is an overview, and so we'll switch. We'll cover the motivation, requirements, problem analysis, and ensemble learning approach, and it's driven by the fact that there are requirements that need different model approaches because of the variety of data out there. And I think that's probably why most, that's the driving factor for most ensemble learning. Sometimes it's in composite models of the same type, like with the inspiration of a random forest. But in this case, it's very different modalities, as you'll see. And in the end, I put together a REST API, and that is the part that makes it a composite. Basically the goal here is to curate long tail research publications. What is a research publication exactly? We kind of know what they're like, what they are. At least the classic looking ones. If you go to archive with an X, .org, with the pre-publication papers, it's like, yeah, this is what a paper looks like. But you'll see some image examples of long tail, which are have a little more variety in layout in a few slides here. So the goal is to curate these. Inner Archive is in the business of preserving data forever. So they're looking for things that are, what would you get first? If you're there's no need to say archive, archive with an X, .org, that site, because they're doing great business, they're well-funded, and they have a lot of content. They publish, maybe 1,000 things a day. So it's unlikely that they're going to go under. Long tail is small publishers that are at risk going under. If they only publish a few articles a year, they're pretty marginal, and they could disappear. So the people who study library science at Stanford, say like David Rosenthal, came up with this idea that these things should be covered and curated and saved. And so they obtained a grant from the Mellon Foundation to fund this work. And as background, there are 18 million research pubs currently cataloged under the fatcat.wiki, and that's the beta version of that. So let's see, I don't think I put that slide in there yet. But it's obvious from the pronunciation, fatcat.wiki. Go there and you'll see. And if everybody goes, it might crash it because it's pretty, I don't know what kind of traffic you can take. We'll see. But that is an example of where, like the 100% curation being done, and more features are being added to that. Things like citation search, right? Detecting multiple copies of the same paper are happening at this with this service. And so there's 18 million papers there now, 150 million PDFs at the Inner Archive in total right now. And that's just from the broad crawls, the same crawls that are doing the Wayback Machine that everyone finds so useful there. And so and if you sample those at large and look at them, you can actually determine that about 6% are actual research publications. So let's say there's about 9 million research publications hiding out there. And so that's what we're going to go get. So the goal is to classify the PDF within 1 second. So the current, if you go to fatcat.wiki, the process of including documents there takes 30 seconds per document. So if you have to process 150 million, it's going to take a long time. And as a reminder, there's only 31 million seconds in a year. So it would take quite a while unless you had a ton of machines, focused on it. So another aspect of this is it's going to be batch processing, which is fantastic. So it doesn't have like an interactive round trip minimal time, and CPU only because they just don't happen to have machines with GPUs, and 48 gig is fine. You can use up to that. The other requirement is we would like to not have false positives because the analysis will require manual intervention to take them out later. The languages will be multiple. There might be Brazilian papers, and Japanese, etc. In fact, I've seen some papers that were in Arabic, so we really have to cover things in depth. There needs to be a REST API. The idea is you just pump the contents, post it of the PDF to it, and it comes back with a JSON. And there's also an API. This is like an additional feature that doesn't go with the classification theme of PDFs. It's just give me a URL and tell me whether you think that a PDF underneath this URL would be a research pub. It's sort of like almost a separate project, but it uses the linear classifier, as you'll see. One of the problems with PDFs, one of the things that could happen is there can be image-only PDFs. There's no text that's easily extracted. So if you look at the PDF contents, the grody details, you'll see like the actual words are in there. But when it's image only, there's nothing. It's just like there's a big block of random looking bits, and they're displayed. And when it gets onto the display and into your mind, then you can read it. But there's no shortcuts to getting to that. We decided not to do OCR in this pass because we need to cover so many languages. We didn't think we had a good handle on OCR. In fact, I think there are researchers improving OCR for Arabic, for instance, right now. Seen some recent work on that. So PDFs also can range over 1 to hundreds of pages, and there can be 1-page position papers and theses out there that have large documents. Various layouts, and you'll see some examples. As I said, I posted some. Added some thumbnails of the documents to this a little bit later, and the variety is bewildering, actually, amazing. The positive data, we have a good set of that because we've got that 18 million documents. We can say, yeah, this is definitely a research work because we have put a rubber stamp on it. The negative cases are like, well, where do you get those? No one has a set of these are not research documents. So it's polluted. It's got about those 6% positive cases. So that's an interesting challenge there. So how to deal with this when you don't do OCR? Well, you could do image, and images classification. We know that at least in the classic case of a computer science paper, if you see a thumbnail of a computer science paper, it's a research work, so the intuition is that should work well, right? But just in case, let's try a linear classifier. So we're going to try a bag of words. Word order means nothing, just number of times the word occurs, and can be used in that case. And then what about BERT? How can BERT, which is the best so far, natural language deep learning network model out there. And it can take 512 tokens up to that. And it is trained on 104 languages. It's gigantic. It's like 100 million parameters, right? So it's a very large network. And there is generalization across languages, which is, if we don't have a lot of examples for training, for fine tuning in a particular language, this would be a big advantage. So as a pictorial summary, it would look like this. You'd have the client makes a request, it sends the PDF to the REST API. REST API then farms it out to the various parts. And so as you see, it's the three kinds: BERT, image classifier, linear. Okay, and of course, everyone has to have a baseline. And so we just dreamed up this one saying, well, what if the word abstract and references, are found? And it turns out that it's actually better than I would expect, at least for English academic papers. It seems to be getting 84% accuracy. So it's an informal test. I didn't write code for this. I just ran it with grep and did my own results matrix. There's two collections of papers: the ones that are English and the ones that are other languages. The other languages, actually other sites, they actually often write in English too, so they may well have the word abstract and references. And also, my references might pull up, somebody's resume, right? So in this secondary collection of papers, it gets only 61% accuracy. So that's pretty crappy. So first thing is like, okay, let's get on the track of images. How can we, use pattern recognition of images to, do the classification? And so one of the best approaches of this is image magic, which actually is remarkably, when I first saw image magic, I thought it was just a way of gluing together images and maybe changing contrast, but you would be amazed the number of things they've added to image magic. The number of things it can process and print. So it basically uses GoScript underneath, but you get a lot of tweaks to say, how can I take this image? So you can say, I want to force it to a certain size, dimensions, X by Y. And you can say, well, if the PDF itself was a different aspect ratio, what are you going to do? Is it going to be upper left-hand corner or what? Or centered? Well, since alignment matters to PDF recognition of research papers, I decided to align them all north and centered. And this is unlike natural images, which basically, if you're looking for classifying an image and saying, is there a cat in this image? The cat could be anywhere, right? So when you can take training data, pictures of cats, and you can crop them, shift them, change contrast, and you can take a small set of data and end up having a lot more data after you get through all with these little augmentations. In my case, in PDFs, we don't have that option. So in training, I tried 7 different models using TensorFlow Hub, which is very good for serving up various models for fine tuning. And Inception and ResNet had the best accuracy. Turns out they're both very recent models. So no surprise there. In fact, I think the accuracy between them was basically identical within 2 digits of resolution. So I ended up choosing Inception with 87% accuracy. Well, that seems a little weak, 87%. But check out this variety. Now, I thought maybe the negative cases would have more things like forms, like you do see tables and things like that often. But the positive cases, none of these actually look like the classic one. I just picked 5 at random from my training set and put them in here. Since I was collecting files, I didn't get to see them until the last minute. And you can see, boy, only the one on the left maybe is the most, kind of similar to what you expect. Like maybe there's a title, you know, maybe there's an author in there. The interesting thing there is you see the language disappears when you get to this, which is kind of a nice feature. Environmental studies tend to put nice green pictures and in the background. So you can see it looks like two of those happened. Sometimes the research work is pretty short, you know, so that fourth one from the left is looks almost like a citation and an annotation of a bibliographic reference. But you know, for me, this is a given. This is what the customer wants, so I can't balk at that and say, hey, are you sure about that? The negative cases, you can see really dense text can come out like with this kind of blobby stuff on the lower left. More images can happen. Newspapers, there's a lot of PDFs of newspaper articles out there. And I guess there we do have a table on the far right. Funny, it's red. Some of the things that can really follow up the, be challenging in the positive cases are when you have cover sheets. Sometimes that happens where a publisher puts a cover sheet that just tells you, you know, their, the licensing or something of the document. That those are edge cases that you know, would be the next level of training and customization of this ensemble would go to. Okay, just to have another picture here. Here's what Inception looks like. I believe that this branch coming out the top there is something that's used during training, but not inference. Oh, and by the way, that's 300 by, no, 299 by 299. That's what it works with. And I trained to 224 square, and during the inference, it resamples. Okay, so now what about the linear classifier? So I picked fast text from Facebook. It's actually a pretty cool implementation, very fast. I think they spared no effort to make it faster. It's a C++ implementation. They have used it to do categorization of up to 300,000 categories. You know, categories such that, you know, a particular instance of something could be in multiple categories. So these are kind of a challenging, sometimes called classification. You know, how do you measure that, right? You've got like, you know, how many cases something was found and should have been in, and maybe in fact, it's a little bit up for debate as to what category something should be in anyway, right? Making it, of course, harder to train. It's a kind of a simple perceptron. It has this, what they call the averaging pool there, and it has a softmax at the end. And did I say it's fast? Yeah, it is really fast. I think it's definitely 1 millisecond or so inference. So it's like negligible. The round trip for the REST request would probably be about the same level. Okay, and okay, here's some interesting things. We heard from another site that curates scientific papers, and they said page width and height mattered a lot, and turns out I couldn't reproduce that. They said it helped a lot. What I measured was 0.3% improvement in accuracy. It requires a separate exec to kind of take apart the PDF and find this one, you know, 2 tokens with numbers associated with them, and we thought it was not worth it to add. I think maybe their data set, their input set was cleaner, and that's why they got a better accuracy. It might be that certain, you know, computer science papers, in fact, maybe they were concentrating on computer science only, those aspect ratios might be much more, you know, straightforward. You can see here the aspect ratios of these positive cases are all over the map, right? Okay, so we also added kind of just say, you know, along with the full text tokens, throw in, you know, the domain name and URI components of the URL. It made no difference. Accuracy, is pretty good, 96%. Maybe that would, could be considered good enough. But however, one of the major goals of this project is to handle this long tail multiple languages. And if you train this and you didn't encounter a language before, you're going to know nothing about a new language, basically, because the tokens, the vocabulary is set during training, and it's also set during training for BERT. However, BERT has 120,000 size vocabulary from around the world, and part of that vocabulary is word components. So it actually factors out larger than that. So it's much more language ready. And so I think this accuracy might diminish with longer tail documents. So, okay, what about that add-on for URL classification? So in the ideal case, okay, you say archive with x.org. Yeah, that's any PDF you find under there is going to be research work. If you look at a PDF under irs.gov, it's not going to be one. So these are like the canonical cases, or archetypal cases, I might say. The it's prone to overfitting, but that might be okay. So the idea is this would speed up crawling, to say, should I crawl this? And so it's kind of experimental. 93% accuracy is actually not so bad. But I think there's a lot of error bars on that. The current training set, I do have models available that we trained for download. And I think that accuracy could be improved. Okay, now on to BERT, yet another model. So BERT is bidirectional encoding representation from transformers. And this diagram on the side here is coming from the original paper. It doesn't tell you a whole lot about the structure, except I should say there's 12 layers in there. And there has a form of attention, which called a transformer. And so what you do is you pump in your single sentence and you output a class. And as I said, it's like 100 million parameters when trained for 104 languages. Okay, the next thing is how do you clean up that training set, the negative cases? So as this is a review here for the positive cases, as I mentioned, but on the right is the process of which I thought I could kind of boost this. So the random PDFs can go through a separate filter and say, okay, well, maybe I can make a preliminary classifier that can help me, and it can be like very heavily rejectful of things that I don't want in the resulting set, like over rejecting. So that's what I did. So what I did is I started with 1,000 negative cases, and that were manually trained, manually curated and filtered. And so then we trained the image classifier on 2,000 cases total, positive, negative. And then, using that, I was able to collect about 10,000, pass over the 10,000 raw examples, and then produce about 6,000 in the end. And so that 6,000 became the negative training set for BERT and the linear classifier FastText. Okay, moving on to the REST API. So imagine it looks like this. There's the URIs are, you want to do a classify. It's the classification is called a research pub, and you can have some choice. So we thought it would be useful to have, for testing purposes, try them all because you want to compare them. And auto meaning, in production, you want to go as fast as possible. So you should try them in the order that they will be useful. And if the confidence is high, don't even bother trying the next one. So for instance, you might be able to take like half the time if you didn't need BERT, if the linear classifier came up and said, well, this looks, quite likely to be a research work. If it was like, confidence 0.7, well, better try BERT as well. So that way the average time can be improved. Okay, and so for example, you can also pick one. Okay, what does it look like? So we, as I said, post the entire contents of the PDF one at a time. We have the overall roll-up called is research in this JSON map. And we have the 3 different components for image, linear, and BERT showing, high 90s, or well, let's say mid to low 90s, values. And also just for traceability, there's a version, text there to say, what model was being used at that time. This is what the URL classifier is like. You post an array, JSON array of URLs, and it comes back and gives you a map that maps those to what its prediction is, or likelihood of being research. Okay, so I'm going to show you a quick demo, and I guess I have to stop sharing and then start again. Let's see, sharing. Okay, I think people can see that. Okay, so I had just gotten this up and running in the cloud. So it's on Google Cloud, and following the instructions inside the repo. So there's a repo. There's actually 3 involved here. There's like one main one for the what I call PDF trio, so for the 3 classifiers, and it uses a specialized BERT. And I'll mention the URL later. So I have, as a netstat, you can see there's the on 3939 is the API service, and in fact, I want to show you how I started it right there. Okay, and I have a test, API test, and oops, let's try that again here. Okay. Now the test, when you run it like this, it's actually takes longer than the numbers I'm quoting because it works better if it's pipelined. When you have 10 requests at a time going in, per second, then you're likely you'll get better results, throughput. But one at a time, there's latency. So for batch, this will be no problem at all. So here, let's see. You can see the results from a document called IA front page. So this is the Internet Archive web page that I turned into a PDF, and I consider, of course, a negative case, and indeed it is. Image-wise, it was a dead 0. Linear classifier also says 0, and BERT says 0.0007. So that's one categorization, classification. Here's another one. I picked a random article somewhere. I'm actually not sure what that one is, but it definitely is very mixed, but low confidence. So basically, it's like it's negative case, but just barely 0.49. And next one, you can see the is a positive case, I guess. Yeah. Okay. So this is the very interesting paper from Google, Hidden Technical Debt in Machine Learning, famous paper, and it definitely scores pretty well, image-wise, and well, the roll-up-wise, certainly it's 0.98. Linear, it's all in BERT also, 0.99 or 0.94 for linear. Interesting. So see, BERT actually does have a little disagreement with linear there, and down here at the bottom, we have another case of, this is supposed to be a research paper, and it doesn't work out too well. So this is one, I think what I did is this is a misclassify that I know about, and I put it in there just to be a challenge. So the roll-up, it is positive. It is saying, yeah, it's 0.66 confidence. It is revealed here that BERT is the one that found it, and oh, in the linear classifier too. But the image-wise, it was a zilch, microscopic kind of number, and that's it. That's the demo. So I did run, you'll see here that I started, just want to say this. So there's 3 scripts at the top level of the repo. So one starts the API server, one starts the image classifier, and another one starts the BERT right there, BERT serving. So each one, the backends of the serving are doing TensorFlow serving, which is a really nice C++ fast thing that takes a TensorFlow model, graph, and variables and serves it up. And it can serve, actually, you only need one TensorFlow serving. You could serve multiple models that way, but for management reasons, I have them as separate here. They could be combined. Because when you make a request to that backend, you tell it which model you want, and it picks like the latest version. For production reasons, you can fold in, you can be running 24/7 without any downtime. You can introduce a new model. Pretty handy. Okay, so I'm going to switch to my refs page. Okay, so there are the pointers to the repos. And I've got one reference to BERT, and here's my LinkedIn page if you want to contact me. And let's see. Now I'm available for questions. Okay, anyone have any questions? You can put them into chat. Okay, so I see one from Eric. Let's see, I've experimented with ML to create variations in the orientation to help let trainable engines recognize patterns even if not oriented correctly. Well, I expect that it's it won't matter. I mean, or won't help because the alignment is a hint, right? So at least for what we think of intuitively as a classic, say, computer science paper layout, and it, you're not going to see all the text forced up in the upper left-hand corner or right, or moved around like that. It's a good hint. And I'll admit I have not actually tested this hypothesis. So, limited budget there for trying that experiment, but it would be interesting to know for sure. So I did, frame the images with, one of the things I had to do with image magic, just as an interesting anecdote there. Sometimes the thumbnail images were coming out black. I was really surprised, and I think they. It turns out that the background is not specified in a PDF. At least most, maybe half PDFs don't even have a specification of the background color, and it's like transparent. And then so I had to force it to be white, and that worked out. Any other questions out there? Well, looks like I'm not seeing any other questions. Maybe people I'll give them another minute or two. Okay, question here about the, is it ASCII based PDF? Actually, the text throughout is Unicode. And I'm not sure what Eric is asking there about bitmap based. I need to clarify that question. Oh, okay. Yeah, well, okay, so here's some other discussion we could say. Well, what if we, along the same theme, I mean, if I did OCR, we could, actually find some text, right? At least partial words, with kerning and everything could actually sometimes be a little broken up. But one of the things that we were thinking of early on was, well, what if we did end-to-end, where we just look at what, the raw PDF stuff, right? And maybe there's some magic giveaway that, well, in research works you see this operator only, and boy, that would be nice. But I thought, well, there are so many different ways of generating PDFs. They each have their own idiosyncrasies. I think that's where we're going to capture that. A style guide for a scientific paper is not going to cause something to have a particular design, maybe a different certain layout, but it won't have a particular instruction in PDF language. Unlikely, I think. And the other reason why we didn't pursue end-to-end like that is that it requires a tremendous number of examples to really do end-to-end. In our case, we actually can get by with 110 to 100,000 samples can be used, and using fine-tuning of an existing model, we can get a lot of traction easily. And maybe it's possible to suss it out with end-to-end with a lot of training, and you can in the end have like a smaller model. That'd be like going custom model. Maybe the model doesn't have to be as many layers, and maybe there is a single neural network out there that can do all of this, or there is something called an ensemble network, or ensemble. What do they call it? I'm sorry, I don't know that recall the name exactly, but there is some research work on multimodal neural networks where you would actually present an image and text at the same time as inputs, and the network can train on both of those. Imagine how that might be a little bit smarter than just combining confidence values with separate networks completely. But as a practitioner right now, the things that are really available are these transfer learning, pre-trained networks, and it would be more of a research project to say, can we make something super custom? I suppose if the compute power had to be really small, it had to be done in a phone or something like that, you could really, go further with that. But those are, that's not the kind of requirements we had. Any more questions? Well, thank you for joining us. I hope you get a chance to take a look at the repo. The PDF Trio has a large set of READMEs, and there's not just the top level, there are lower level READMEs. And I tried to make them, such that you could follow along and rerun this yourself, and also to do training. Training is a little more complicated, but all of the tools are there. There are, data prep. Each you take in text, say for instance, in linear classifier or the BERT, and you've got to put them into the idiosyncratic, CSV or TSV file that each one requires, and then train on those. So that just that's one of the things that make this machine learning project more focused on data prep, as is typical, than tuning any kind of network. I want to give you a tip though about fast text. Tuning didn't matter. No matter what I did, it worked well. I'm pretty happy with fast text. It's almost, well, foolproof, you might say. I guess the fact that it doesn't have too many layers, maybe that's what makes it foolproof. Okay, thank you. Yeah, right. Yeah, it's try it out. Yeah, FastText. So you can FastText actually does compile for your local machine. There's a one thing I found out today was that you need G++, to actually use FastText Python. I didn't know I had it already before, and this morning I did it on a stripped down OS that was like cloud ready and very little on it, no compilers, and so when you actually do the pip import, it fails, which is like, whoa, wait a minute, and I'm expecting a ton of errors from that. But yeah, it actually does compiling as it installs itself. So there's pip installs can be pretty sophisticated, and that actually is consistent with FastText. They are very sophisticated. They just go all the way in the C++ compilation world, and they actually matter to them exactly what instruction set your CPU has. Okay, well, thank you all, and I'm happy that you have joined me, and I'm glad to share.